Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. Today we're going to be introducing a new series, and the series is going to be on power rule. So basically what I'm trying to explain here, first of all, is that power rule is one of the most basic differentiation rules. So what I mean by that is you have to power rule, understanding power rule. Let me just write all of that down. Power rule very well or properly would allow students to have an easier time with more advanced rules such as number 1, product rule. Number 2, quotient rule. Number 3, chain rule, etc. I'm using etc. because after you can properly understand power rule, then you'll be exposed to doing product rule, quotient rule, chain rule, exponential, like differentiating exponential functions and things like that. You could even be given more questions such as word problems. But one of the most basic things you have to learn is power rule. And I'm starting with this explanation because I don't want you to just come into this series thinking, oh yeah, we're just doing power rule and I'm just going to stick to doing maybe what some professors that don't go into detail do, or what other people maybe on their channels do. I want you to first understand that this rule is so important and so basic in comparison to other rules that not properly understanding it is going to actually prove to be difficult when you start doing other differentiation rules such as product rule, quotient rule, chain rule, and all the other differentiation rules that you're going to be learning in calculus 1 and 2. And even because having a strong foundation of this would definitely be of benefit when you take more advanced courses. So that's the first thing I wanted you to know. Now, before going into what power rule is by itself, we have to go back to the foundation, right? Because not everybody has the same level of math background. I want to be able to keep everybody on the same level as much as possible. So whenever you are given a question, right? First of all, let me just put some random quantities at the top. So x raised to power 3, y raised to power 4, m raised to power n, q raised to power f, b raised to power 9. Actually, this one is so close. X raised to power 3 so close to that left. X raised to power 3 and O raised to power 7, right? So now I could ask you all of this. What does this quantity look like? This quantity looks like a quantity where there is a base and there is a power. So a base is what is at the bottom. Let me write this at the bottom of the page. A base is the quantity at the bottom. at the bottom, and the power is the quantity at the top. Okay, so now that you already have that, let's start working, right? So here I'm going to ask you, identify the base and power of the following quantities, right? So number one, here let's have power first, and then we can have base, because I want like it to be something you'll be able to point out. And then you have base. Okay, so let's use a different color now. What is the power in y to the fourth? The power is 4. What is the power in m raised to power n? The power is n. What is the power in q raised to power f? The power is f. What is the power in b raised to power 9? The power is 9. What is the power in x cubed? The power is 3. What is the power in O raised to power 7? The power is 7. What is the base in y to the fourth? The base here is y, and as well as the power here is 4. What is the base in m raised to power n? The base is m and the power is n. What is the base in q raised to power f? The base is q, the power is f. What is the base in b raised to power 9? The power is 9, the base is b. What is the power in x raised to power 3? You know that the power is 3, but what is the base? The base is x. And what is the base in 0 raised to power of 7? The base is, sorry, not 0, O, the alphabet O, right? So that's it. Now let me give you more unique looking questions, right? So this is the first, and then let's go to the second set. What is the power in x plus 4 plus 11q in this, in m raised to power m here? What is the power of n minus 7 raised to the power of 2x? Sorry, not 2x, not 27, 2x. I don't know why I just put 27, that human error. And what is the power of 19 minus 54y in raised to the power of 0? So the answer all of these cases is this. So this is the power here, and this is the base here. Okay, so this is what this is right here, power. And you have x plus 4 plus 11q raised to the power of m. The power here is m, while the base here is every other quantity, which is x plus 4 plus 11q. I'm sure you're like, dang, this tutoress is just something else. Like, I just want to get straight to the rule. But no, I want to like break this information down, especially for students who struggle. So now we're going to ask, what is the power of n minus 7, all in bracket raised to power 2x? The power is 2x. What is the base of this? Is simply n minus 7. Now the last question. What is the power of 19 minus 54y, all in bracket raised to power of 0? The power is simply 0. And what is the base? The base is 19 minus 54y. And one thing I need to mention though is this, right? Anytime you see a power raised to the power of 0, anything, a form of a quantity, a variable, or a number raised to the power of 0, you're always going to get 1. So you see 19 minus 54y here, all raised to the power of 0 equals 1, right? M raised to the power of 0 equals 1. Yes, so say 2x to the 0 equals 2, because 2 times this equals 1. So 2 times x to the 0 equals 1. Or even giving you a question such as 7 raised to the power of 0 equals 1. So even if it's a constant, as far as 0 is its power, it's always going to give you 1. So that's this for the very nice introduction. So that's basically it. Now that we've already worked on that, the next thing I want to explain to you is basically what is the power rule. So before we do that, let me first of all explain to you that when you're given a function, so a function say y of x equals something, in this place x raised to power n. Let me make this a box here. To be able to apply the power rule, we have to understand that the way the function is supposed to look like, way the function is to look like. To be able to apply the power rule, we have to understand the way the function is to look like, which is true. So it's important for you to know this. First of all, whenever you're doing power rule, the n here, the power, n in this particular case that I have circled in green, has to be a non-zero real number. So what does that mean? N cannot be equals to 0. In order for you to apply the power rule, you cannot have a question like x to the 0. Oh, what is the differentiation of n to this x to the 0, right? You cannot have that. You cannot apply the power rule in a question like this. Apply the power rule. You cannot. You just cannot. That's not how the rule works. So it has to be a non-zero real number. That's 1. 2, you cannot have an imaginary number. So you cannot have x to the 2i or you have x to the 2j plus I. You cannot have that. The number has to be a real number. You cannot in any way, shape, or form have an imaginary number. So when I say 2i here, it's the same thing as saying, okay, you cannot have x to the square root of a negative root. You cannot say, oh, negative root 4. This is something. No, you cannot apply the product rule, because whenever this square root of a negative number comes into play, the number loses its realness. It becomes an imaginary number. So that's just basically what I wanted you guys to know. So you cannot apply the product rule to something that looks like that, right? You cannot apply it to a variable raised to the power of 0 or a variable raised to the power of the square root of negative something. So if one of the questions in your assignment is saying, oh, use the power rule to solve x to the negative 9, just say power rule cannot be applied. Okay, power rule cannot be applied. I just wanted you guys to know that. You cannot apply the power rule to such a question. So yeah, that is basically it. So let me just continue. I'm going to continue with a blue marker. So yeah, so no, the number cannot equal 0. The number cannot equal an imaginary number. Okay, cannot equal an imaginary number. So that's really it. That's basically it. Yeah. So yeah, so that's basically the answer. And you have y to the x equals x raised to the power of n. And yeah, so if now that you understand that what n can be, you understand that x is the variable or x is the base. Now when you want to apply the power rule, that is when a differentiation occurs. So applying the power rule means differentiation. Is also meaning like you're going to apply differentiation. Apply differentiation. So now what you now have is the same thing as saying, oh, what do you get when you do d over dx of x raised to the power of n? So this is what you get. To differentiate it, when you apply differentiation, the n here, which is the power, like I had explained to you what power is. In this case, power is 4, power is n, power is f, power is 9, power is 3, power is 7, power is m here, power is 2x, power is 0, right? Power is all of this stuff. Power is all of this stuff, right? So in this particular case, the power is n. We're going to drop down the power to be the coefficient of x. So n is going to come forward. It becomes the coefficient of x. Then you have x here, and then you have n. So when you bring down n and it becomes the coefficient of x, what happens to the rest of the information here? What you have to do is to decrease the power by 1. So in this particular case, the power is n. Decreasing the power by 1 is going to be n minus 1. So you have n x raised to the power of n minus 1. So this is basically what happens. And this is simply an introduction, very unique introduction. So now that we've understood the power rule, we have to understand other rules as well. And now we have to understand the sum / difference rule for differentiation. This is also very important. For differentiation. So what you're saying is, if you're given a function and within that function, so say you're given a major function, a main function, y of x, right? And that function comprises of mini functions, right? So mini function 1, mini func 1 plus mini func 2 plus mini func 3, or let me not even put plus, it could be minus, right? So plus or minus mini func 3 plus ... What this is saying is that when you're putting a difference in a situation where you have to differentiate, you can differentiate each one of the functions and add them all up. So you differentiate, I'm not even gonna write, let me write it down. Differentiate each one of the functions and add them up. So that is that one as well. So now what we have is f of x, if you're given y of x, oh subhanallah, oh my gosh, what's going on? I don't know why the pen isn't working. Please work. Students need to learn. What's going on? Okay, you guys, so now that the pen is back to working again, so let me now basically write what I wanted to write before. If you have, like I said, meaning functions, you have y of x, right, equals f of x plus or minus g of x, right? I'm not going to do a whole bunch, because the truth is, when you want to add something up, you can even add them, like you just keep adding them. That's why I put the dot. It's just like saying, oh, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. I'm not going to keep saying that up until like a billion. I can just put plus dot. So in this particular case, we're just going to use two meaning functions or two sub functions to be able to explain how the rule can be applied. But it's also possible for you to have more than 10 mini sub functions, even though professors tend to give between 2 to say 6 or 7 mini sub functions. But I'm just going to stick to 2 because that's really what everyone sticks to, and I don't want to confuse anyone. So yeah, so this is it, right? Y of x equals f of x plus g of x. When you apply differentiation, like we're going to do now, we get y of x, the differentiation dy dx of y of x equals d of dx of f of x plus d of dx of g of x. Now, remember I did plus or minus here? I'm going to also include the plus or minus here. It doesn't matter. When this is not plus or minus, like this is what it's going to look like. It's just saying that you could end up with two meaning functions added up, or two meaning functions with a subtraction in between them, or with a plus sign in between them, or with a minus sign in between them. It could be any of the two. So that's it. Yeah, that's basically it. So that's the sum and difference. There's nothing super special. Now let me go to the very last thing before we actually start solving problems. This last one is constant, right? Whenever you're told to differentiate, whenever a function is multiplied by a constant, how do we differentiate? Asking you guys. So it's just basically saying, how do you differentiate when, say, we have k, a constant, multiplied by f of x. So how do you differentiate such? You just do d over dx of k that is multiplied by f of x. How do I differentiate this? It's just basically bringing out the constant, nothing super wow. So this is going to be k. Now that you have that, you now have a bracket, you bring out the k. That's just going to be d over dx differentiating f of x. So basically what I'm saying is this: they give you a function multiplied by a constant, you bring out the constant, and then you multiply that constant by the differentiated function. So even though your initial question is a constant, right here, use a red marker, multiply by a function, to differentiate it, you bring out the constant and just focus on differentiating the function. That is it. That is basically it. Yes. So it's like saying, oh, what is the differentiation of 2x, right? Now, let's do d over dx of 2x. They're asking what's the differentiation of that. It's the same thing as bringing out 2x, right? Sorry, the same thing as bringing out 2, right? And then differentiating x. So that's the same thing as, that's why whenever you differentiate 2x, and I think by this time you should kind of understand, how that works. Is also basically the power rule. The exponent of, the power of x here is just 1. When you bring down 1 in front of x and you decrease the power by 1, which is 1. 1 minus 1 is 0. So that's x raised to the power of 0, which is 1. 2 times 1 is 1. That's basically the answer. But anyways, that's just quickly. We're going to do problems soon. So you have d over dx of x. So you get 2, bring that out, and you differentiate with respect to x. So you have 2 times 1, and that's why your answer here is 2. Bring out the constant. So in this case, bring out k, and in this case, bring out 2, and just differentiated. What else are you given? So that's it. That's how you differentiate constants. Bring out the constant and then differentiate. That's how you differentiate constants that are multiplied by function. You bring out the constant and then you focus on differentiating the function. So now you can ask too, okay, what is the differentiation of a constant, right? What is the differentiation of a constant? Say, what's the differentiation of, what is differentiation of any constant? The answer is always going to be 0. 0 is the answer. Always 0. So if they ask you what's the differentiation of pi, like what is the differentiation of pi, that's going to give you the 0. What is the differentiation of e to the 2? That's going to give you 0. What's the differentiation of a billion? That's going to give you 0. What is differentiation of c? In this case, c is a constant because there's no variable of x in this question. That's going to give you 0. What's the differentiation of 1.75 m? The answer is going to be 0 because 1.75 m is a constant. You may be wondering, but m is a variable. No, m is a constant in this case because we're differentiating with respect to x. If we're differentiating this question with respect to m, then m is going to be a variable. But in this case, we're differentiating 1.75 m with respect to x. So 1.75 m altogether is a constant. All of it is a constant. 1.75 is a constant, m is a constant. 1.75 m therefore is a constant. And when you differentiate with respect to x, for sure is a constant, so you're going to get 0. So now that we've covered the basics, let's do a problem applying all of these rules. So let me give you a summary of what the rules look like. You have power rule, and power rule is x raised to the power of n prime, also known as d over dx, x raised to the power n. What you end up with is n x raised to the power n minus 1. Okay, that's power rule. Then sum and difference rule. And then just basically constant multiplied by function. by function. So that's that one. It's also here, if you have f of x plus or minus g of x prime. Okay, so you end up with f is the same thing as saying d over dx. So let me erase this. Same thing as saying d over dx of f of x plus or minus g of x. What would you get? What you're gonna get is d over dx of f of x plus d over dx of g of x. So that's it. That's that one. And then here, I'm using prime here. I'm going to explain what's going on. It's the same thing here, right? Or, in this case, you can also write it as f prime of x plus g prime of x. Or plus or minus g prime of x. I don't know why I keep forgetting the minus. So that's that one. Same thing here when you have k multiplied by f of x and its prime here, same thing as d over dx, k multiplied by f of x. So when you have that, it's the same thing as saying k of f of x and all of this prime, or k d over dx f of x. So that's basically what it can be. What my point is here is your professors might use the prime on top of what you're differentiating, or they might just use d over dx. For this video, I'm going to be using d over dx, but normally as further videos come, not just in not in power rule though, in other rules, I'm going to stick to using prime and maybe sometimes use d over dx purposely, just because I like my work to be neater, and using prime is a lot neater, but you can use any of the two. Just pick whatever you're most comfortable with, or whatever your professor will prefer you use. So that's that. So yeah, so that's that. Now let's jump to a question. It's like, dang, when are we gonna get to a question? Well, now we're in a question. We have a question. So we have 5 over 6 x cubed minus 7x plus 16. And you're wondering, how do you solve this? Well, the first thing you have to do is check whatever the powers are, right? What are the powers in this question? So this is it. They told us that we have to differentiate. We can see from the question that this is a power. This power here is 3. This power here is 1. Because anytime you have a variable sitting by itself without any evident power, like the way we have 3 here, or maybe we don't have something that looks like x squared. If we don't have any evident power, we're going to give that means the power is 1, right? So if we just have m sitting by itself and m is a variable, guess what? 1 is the power. If we have x sitting by itself here without any power, the power is 1. And this is just simply a constant, right? So now how do you apply what we've learned? So now we go back. Let me use green. It's a beautiful color. So we have d over dx y over x equals 5 over 6x cubed minus 7x plus 16. So that is it. Then you have d over dx. Let me just stick to 5 over 6x cubed minus 7x plus 16. So this is equals to d over dx 5 over 6 x cubed. Now guess what we're applying? We're applying the sum slash the difference rule right here. First of all, that's what we're gonna apply. Just keep watching. So that's that one. Plus or minus, because we have a minus here, d over dx, right? D over dx 7x plus d over dx of 16. So how do you solve this? The next thing you end up with is d over dx five over 6 d over dx x cubed here, okay, minus, bring out 7. Remember what we did here? Remember what I talked about by the constant? And when we're dealing with constant, we have a constant multiplied by a function. In this case, like we see here, we bring out constant and then we differentiate the function. So guys, that's what we're doing here. I brought out 5 over 6 and I'm differentiating x cubed, which is the function. X cubed is a function, which is the main mini function basically. 7x, I'm bringing out 7 and I'm going to differentiate x. So d over dx, right? And differentiating x plus, what did I say the differentiation of a constant is? If you look at this page here, differentiation of any constant is always 0. So I'm just going to put a big 0 here. So now that we've done that, we can now start. Now, what rule are we going to apply here? First of all, we did we arranged it using the sum slash difference rule, and then here we applied the constant multiplied by the constant multiplied by what they call it, constant multiplied by function. Basically, I don't want to call it a rule, but fact, I guess, mathematical fact. So that's that one. And then, or we can just pretend it's a rule for this video, to be honest with you. So, and then we have that. Now we're going to apply the last thing, apply product rule, apply power rule. I keep saying production, power rule. Product rule is a whole nother rule, guys. Don't be confused, please. So you have, here you now have 5 over 6, right? And then you apply the power rule. So you bring down 3, because you imagine 3 is that n that I always talk about. Then you have x, and you're going to decrease the power of 3 by 1. So that's 3 minus 1, right? Minus 7. And then you see here. What is the differentiation of x or a variable sitting by itself? It's just 1, but let me show you the process. You have x here, right? What is the power of x here is 1, so you bring down 1. Then when now 1 that is the power has to be decreased by 1. 1 minus 1 is what? 1 minus 1 is 0. So plus 0 here, we don't have to bring plus 0, so we end up with 5 over 6 x3 multiplied by 3x squared minus 7 x to the 0. So let's go to the next page. So you have 5 over 6 multiplied by 3x squared minus 7. Now, what did I say whenever you have a variable raised to the power of 0 is a variable raised to the power of 0 is always going to give you 1. A constant raised to the power of 0 is always going to give you 1. Any quantity raised to the power of 0 is always going to give you 1. That is it. That's just how it works in this math. So now we have x to the power of 0 is the same thing as times 1, right? Because x to the power of 0 is 1. So now that you have that, now we're going to multiply everything together. In this case, we have minus 7. And then here we have 5 times 3 is 15 divided by 6. But obviously, this is simple math. So we just do 3 here 1, 3 here 2. So what we end up with is 5 over 2. And then we x squared minus 7. So what is the differentiation of all of this? The differentiation of 5 over 6 x cubed minus 7x plus 16 equals 5 over 2x squared minus 7. And that is basically your answer to question. So this is it. It only took you 41 minutes, but I have to break every information down as best I can so that you guys would be getting quality videos, inshallah, which has always been my goal. And I wish and hope by the grace of God I'm going to continue this video. Allah subhanahu wa ta'ala help you guys in your various endeavors. Same thing if you're not Muslim, Allah subhanahu wa ta'ala is God. It's just basically talking about Almighty God. Almighty God. May Almighty God help you guys in your exam. May Allah subhanahu wa ta'ala help you guys in your exam. And may Allah subhanahu wa ta'ala guide you guys and protect you guys. So if you have any assignments, you have any questions you want to ask, please put it down in the comment section. I am going to try my possible best to answer the questions. And I'm also a personal tutor. So if you're looking for personal tutor services, please look at my email in the description box. And please subscribe, like this video, it helps with the algorithm. Leave a good comment down and leave your suggestions down. I also wanted to mention that I'm currently looking for a video editor, someone who is going to be there to edit the videos so I can focus more on making videos and spend less time editing videos. And I hope this is helpful to you guys. May Allah subhanahu wa ta'ala assist you. So if you know anyone who is good with editing videos or you're good with editing, you can send me an email. It's going to be a paid position, inshallah. And yes, that's about it. May Allah subhanahu wa ta'ala make it easy for you guys. Assalamu alaikum wa rahmatullahi wa barakatuh.